Hi, how's it going? Here today, I've got just kind of a follow-up to our intro program. We've got our test program here running. You can see we've got our counter that's just testing up constantly. I know a lot of people like to program in other languages, so I'm going to show you how to change this default project over to another language. First off, let's go ahead and log out, and we're just going to exit out of this program. So if you're just starting this up, we can right click here on main and delete. It'll say, hey, you sure you want to do that? Click yes. Now right click on the POUs folder and add POU. So there are a few checkboxes here that we want to be aware of. The first is the name. Obviously we want to give our program a meaningful name, so I'm just going to call this um, main task, maybe. That kind of makes sense for this. It's really not a big deal for this project. It's a test program. So now we've got the types down here. We've got a program, function block. We've got some extends and implement stuff that's object-oriented stuff. We've got an access specifier, and we've got function. So we can make it either a program, a function block, or a function. In this instance, we're going to want to make it a program. I'll get into what function blocks and functions are later. That kind of deserves its own video, each one of those. So. And down here is the implementation language. So we've got several to pick from here. Say, for example, I know in the U.S. a lot of people like ladder. That seems to be the go-to for a lot of guys. That's what a lot of trade schools teach, and that's what I learned when I was in trade school. So go ahead and use the ladder logic. We've also got continuous function chart page oriented. These two are very similar. The main difference is that with continuous function chart, it's very similar to function block diagram, except that you're less restricted on where the blocks go. Function block diagram is very similar to ladder, especially in Twincat and with IEC 61131. So the function block diagram is just kind of a list of function blocks, and it is kind of nice for Boolean type logic with a lot of ands and ors and stuff like that. Then there's ladder, sequential function chart. I had never heard of sequential function chart until I started getting into Beckhoff. Beckhoff was sort of my first foray into IEC 61131. Um, Sequential function chart is meant for doing sequences, so where you have a specific sequence of events that a machine needs to go through or that a plant needs to go through. It's really, really good for that. That kind of deserves its own video, maybe its own even series of videos. There's structured text. That's kind of what Beckhoff leans to. That's kind of what Beckhoff leans to for the most part. It's I don't know. It's structured text. It's if then else and if for do next that kind of thing. And there's UML state chart. I really don't use that one much. It's really not. It's more of an object-oriented kind of mentality that kind of deserves its own video. So we'll go ahead and create a ladder logic program. Oh, sorry, I can't name that the same as my task. I'll call it main POU. So we've got our ladder here. We can go ahead and if we click on the toolbox tab, we can see all of the instructions that we have available to us. So up here is where variable declarations are. There are a couple of ways to do this. The first is to manually type them in. I mean, I can come in here and declare a Boolean, like let's create a motor starter circuit, a really basic motor starter. So we're going to need a stop button, a start button, and the coil for our motor starter. So I'm going to call this one BTN for button. Personally, I like to preface my variables with kind of some indication for what they are. So I'll call this one button start, and I'm going to tab over a couple of times, and then we'll call it a bool, and then semicolon, tab over a couple more times, and comment, comment, comment. I cannot emphasize that enough. And we're going to call this start button. So Alright, so this is a start button variable, or a Boolean variable that we've created. That's one way to create a variable, is to just type it in like that. Personally, that's the one that I use the most, mainly just because I kind of started with Twincat 2 and I got used to it. In Twincat 3, which is obviously what this is, there's more of a table view. It looks a lot cleaner, I think, but there again, I'm just used to typing them in by hand, and I don't think it's that big of a deal. So we can create a new variable here. We'll just start typing. We'll call this one button stop. And address we can leave blank. That's really not important yet. Data type is going to be a bool. That came up correctly. Initialization, this is where you can set a default value. So say for example, we wanted, when the program first starts up, we wanted our stop button to default to true for some reason. We could type in true here, and it would implement that. Actually, I'm not sure if that's really the correct syntax. There again, I think it might be. Yep, that's the right syntax. Again, I don't use this part of it very much. And so then here's our comment section. We'll just call this stop button. And we'll create another one down here. We'll call this our coil. And that's going to be a bool again. There we go. So we got 3 variables here created. This is really, I mean, anybody that's been in PLCs knows that there's a million ways to program anything. And like everything else, of course, there are a million ways to program a motor starter. I'll do a couple of them here, just kind of as really light, quick examples. We're going to have Boolean operators, ladder elements. That's what we want. So we've got our first network here. It comes up with one already there. We can right-click and insert network down below that if we want more rungs. Or we can copy-paste also. So first thing we're going to need for our motor starter is contact. It's going to be a normally closed contact. Let's see, a gated contact. And we want that to be our stop button. So we're just going to call it button stop. It may underline it in red and make it think there's an error. Twincat doesn't really evaluate syntax unless you do a build, so that is Control-Shift-B. If you do that, we actually do have an error here because we deleted our main program a while back and didn't add a new task. But our underline here went away. I'm just going to fix that quick because that's going to bother me. So let's right-click, delete, OK. Right-click, add existing item, main POUs, main POU, right there. Alright, so now we should be good. Here again, if we do just another build, I'm not sure why. Not stop button is no valid statement. It may like that, or may not like that we don't have a coil. Let's try putting one in there and see what happens. So we put our coil in there, and oh, I hope if I typed it in right. Didn't have any question marks. There we go. So there we go. We've got our stop button that'll drop out the coil whenever we press the stop button. We've got, and then we need a contact, and we'll type in coil here again. And then we need to right-click and insert branch parallel, or actually we can just insert a contact parallel below. And we can call this one button start. So now if we do Control-Shift-B, we're good to go. There are no problems. And we can log in. It may ask me to activate because I changed that task. Looks like it did not. We're good to go. So I can simulate buttons here and simulate values by just double clicking on them, and we can see that changes from true to false. It puts them in there for us. So I'll just simulate a start button press here. So the user presses the start button and then releases it. Our coil stays on. User presses the stop button, and the coil shuts off if we release the stop button again. There we go. So this is a simple motor starter latch. Like I said, there are a million ways to do it. This is just a quick, easy way to do it in ladder. Um, that's pretty much it. So that's how you can change your project over to ladder, and kind of just a brief overview of how you program with ladder. Thanks for your time.